Hi everyone, Mr. Boltri here bringing you video 3.9. We're going to talk about how to quantitatively solve force diagrams. So quantitatively means with numbers. So this is going to be the last major topic that we talk about in Unit 3, the forces unit. So first, let's talk about quantitative forces. So in our classes, we've run two experiments that have given us these two equations. Force gravity equals -10 times the mass, or force gravity equals -9.8 times the mass, depending on if you want to make the calculations easier or if you want to be a little bit more accurate. And the reason why I've added this negative sign in here is because the direction of force gravity is always down. So in this video, when we're talking about forces that are going to be in the downward direction, we're going to put a negative in front of them just to help us remember that negative means the force is down, and so then a positive means the force is up. In the same way, forces to the right we'll say are positive, and forces to the left we'll say are negative, just so that when we add them together, if they sum to 0, we know the forces are balanced. If we have 15 newtons up and 15 newtons down, it's going to be +15 plus -15 equals 0, means the forces are balanced. And we also found the force of the spring equals the spring constant, which is the constant for any given spring, but it may be different from one spring to the next spring, times how much the spring is stretched. So the spring constant times the stretch. So now we can use these force equations to solve for various quantities in the situation. And I figured the best example, the best way I could show this to you is to just give you an example of the kind of problem that we might solve. So if you're given this spring, and so the first thing we should think is to write down the spring equation. Because remember, if you write down the equation, then I can at least give you partial credit, and it's better than leaving it blank. And then let's say we have a box, and the mass of the box is 15 kilograms. And then when we put the box on the spring squishes, the change in length of the spring is 0.4 meters. And then the question asks, what is the spring constant for that spring? So the first thing I'm going to want to always have you do, always, your first step is to draw a force diagram. Always draw a force diagram first. Always draw a force diagram. Always draw a force diagram. So in this situation, we're going to draw a force diagram for the forces on the box. Obviously, pulling down on the box is gravity, and pushing up on the box is spring. Because if our first step is to draw a force diagram, first step, draw a force diagram, then we're able to understand the situation a little bit better. We can figure out that if we solve for the force gravity, then that is going to equal the force spring, because we know these two forces are balanced according to Newton's first law. I guess we'd have to be told in the problem that the box just sits there, it maintains a constant velocity of 0 meters per second, but if we're given that information, then we know these two forces are balanced. So if we can solve for force gravity, then boom, all of a sudden we know the force spring, and that's really useful to know the force spring in solving the force spring equation. So then we write down our force gravity equation and substitute in for the mass, which we know, and thankfully it's in kilograms. Remember, this mass has to be in kilograms or else it won't work, and then it gives a force in newtons. So the -10 times 15 gives me a -150 newtons, which means 150 newtons pointing straight down. So once I get that number, I can add it to my force diagram. So it's very good that I drew my force diagram in the first step. So I have -150 newtons pointing down. So therefore, I know the force spring is 150 newtons pointing up, because we were given in the problem that the box is maintaining a constant velocity. Once I know the force spring is 150 newtons pointing up, it just becomes a simple problem of substituting in the stretch, substituting in the force, and solving for the spring constant. This is in newtons, this is in meters, so our spring constant is in newtons per meter. And then all of a sudden, we have our answer to our problem. So just to give an overview of what I did, the first thing I did, and the first thing always to do, is to draw your force diagram for the situation. The next thing is to make sure you have a very clear sense of the stuff that you know, and then write down the equations that you're going to need to use. In this, we know that we need to use force gravity and force spring. Substitute in the known stuff into those equations, and then solve. Force diagram, write down the knowns, write down the equations, substitute, and solve. That is the best way to solve a problem involving a force diagram. So the last thing I want to talk about is, so that was all well and good when the forces were pointing straight up and straight down. But what about when the forces are pointing off at an angle, which we've done in our advanced force diagrams, and you will have a problem involving a force off at an angle. Let's say that we have this force, which is up and to the right. And we remember from when we talk about this in class, this means that this force is partially to the right and it's partially up. So we can think about how much it is to the right by just saying this is the x, the horizontal component of that force. So this force is made up of a horizontal component, and component is a word, just means piece or part. So I can say it's made up of a horizontal part and then a vertical part, or a horizontal piece and a vertical piece, horizontal part and a vertical part. And so let's say we're given the problem that the horizontal component is 4 newtons and the vertical component is 3 newtons. And then we're asked, what is the magnitude of force F? So we're basically asking, how long is this pink arrow? If we know that it goes 4 to the right and it goes 3 up. Well, a lot of people are tempted to say that the answer is going to be 4 plus 3. The answer is going to be 7 newtons, which would be true if these two arrows were pointing in the same direction. We could just add them together. But they're not pointing in the same direction. One goes to the right and then one goes up. So in order for us to find this diagonal arrow, we actually need to use something that we've learned from math class. You'll notice that this looks a lot like a right triangle where we have legs of A and B and then a hypotenuse of C. And you'll remember from math class that in order to find the length of side C, which is the magnitude of force F, we use the Pythagorean theorem, which is a squared plus b squared equals c squared. Now, instead of using A and B, what we really have is we have the horizontal component, and the vertical component is going to give us the magnitude of the force. So 3 squared plus 4 squared equals the magnitude of the force squared, or another way to say that is the magnitude of the force equals the square root of 25, or the force, the magnitude of the force equals 5 newtons. So it's 5 newtons, which is in the direction of up and to the right. So that's why I'm not going to ask you the magnitude and the direction, because the direction would be complicated to say. You'd need to like calculate the angle here, and we don't really have all the tools to do that yet. You're going to figure them out soon in your geometry class, but I don't really want to teach you that. So all I'm going to ask you for now, and then maybe later next semester I can ask you more complicated questions, but for now I'm going to ask you, what is the magnitude of this force if you're given the horizontal and vertical components, and then you know to use the Pythagorean theorem to solve for the side length of the hypotenuse of this triangle that's formed here. So please let me know if you have any questions. We are going to do a lot of practice problems involving quantitative force diagrams in our next class. So hopefully that'll clear up any questions that you have. But I want to know if anything is confusing you about this video. But for now, this is Mr. Boltri wrapping up video 3.9 on quantitative force diagrams, and go Bears.